In this lesson, I will show you how you can use the matrix row reducer to find the determinant of a square matrix. Suppose we have to find the determinant of this 4 by 4 matrix. What we will do is use row operations to get zeros in these places. That will leave us with an upper triangular matrix, and the determinant of a triangular matrix is simply the product of the numbers on the main diagonal. So let's bring up the matrix row reducer and enter the matrix. Let's see, it has 4 rows, so we change the 3 to a 4, and it has 4 columns because it's a 4 by 4 matrix. Click on OK. And then we enter the numbers of the matrix. Let's see, 5, 2, 1, 3, 3, 0, 1, 2, 4, 3, 5, 1, 1, 2, 3, 4. Okay, we have the matrix in here. What we are going to do is clear the first column so that it has zeros below the top row. And then in the second column, we want zeros in the last 2 positions, and in the third column, a 0 in the last position there. So I'd like to use the first row to clear the zeros below it. And I don't like the fact that the first row begins with 5, because that means I would have to use fractional multiples in order to do that, and I don't like to work with fractions unless I absolutely have to. So at the beginning, what I'm going to do is swap the first and third rows, put asterisks, or first and fourth rows, put asterisks in the positions of the first and fourth rows. But when we're working with determinants, if we swap 2 rows, we end up multiplying the determinant by -1. So I'm going to bring up a scratch pad here and keep track of that fact. I'm going to have to divide by -1 at the end because I ended up multiplying by -1 when I swapped the rows. Click on Calculate, it swaps the rows. Okay, now I'm ready to clear the zeros below the top row. If I add -3 times the top row to the second row, -3 times the top row to the second row, I'll get a 0 where I want it there. There we go. And then I will add -4 times the top row to the third row to get a 0 there. And finally, I want to change the fourth row by adding -5 times the top row to it. That way I've got my 0. Okay, I've got my zeros here. Now I want to go over here and get a couple of zeros. I'm going to use the second row to do it, not the first row, because that would reintroduce non-zero numbers in the first column. The second row consists of all negative even numbers, so I can simplify the second row if I multiply it by -1/2. But when you multiply a given row by a number, it also multiplies the determinant by that number. So on my scratch pad here, I'm going to indicate that I have to divide by -1/2 at the end. All right, let's click on Calculate. Now I have a simpler second row, and I want to use the second row to clear the third and fourth rows. Let's see, 3 and -5. I'd have to multiply, I want to change the third row, I'd have to multiply the second row by some fraction in order to make that 3 into a 5. And again, I don't like fractions. How about if I multiply the third row by 3? Oops, if I'm going to do that, I've got to remember to divide by 3 at the end. All right, we're going to multiply the third row by 3. That gives me -15 at the beginning here. And so I can easily clear that to a 0 by adding 5 times the second row to it. So 5 times the second row added to the third row doesn't change the determinant, but it gives me my 0 where I want it. I want this -8 to also become a 0. Once again, to multiply 3 by a number and get 8 requires a fraction, and I'd prefer not to do that. So let's multiply that fourth row by 3 first. Again, I have to remember that if I'm going to do that, I have to divide by 3 at the end. All right, let's see what happens here. Okay, I get negative 24. Now I can add 8 times the second row to that fourth row to make a 0 there. There we go. Okay, we've got one more 0 to get here, and I want to use the third row to get that 0, not the second row, because that would reintroduce a non-zero number here. So let's see, if I want to change the negative 10 to a 0, I've got to add negative 10 times the third row to the fourth row, and that does not change the determinant. So calculate, and there we go. Now we've got our triangular matrix here, and we can look at that on the screen. This is the triangular matrix that we ended up with, and let's see. What we know from the scratch pad is we multiplied the determinant by negative 1, negative 1/2, 3, and 3. And so we're going to have to divide by those numbers at the end. And this determinant here, let's see, we can get this determinant by simply multiplying the numbers on the main diagonal, which are these numbers here. And so if we pull out the calculator and do the calculations, we get 4.5 times the original determinant is negative 567, which means the original determinant is negative 126. And that's how it works. But of course, that's a bit more work than using a graphing calculator or some program such as Microsoft Mathematics.